Hi everyone, let's do this Cambridge math problem. Let's say we are asked to simplify this expression. We have 10 plus square root of 24 plus square root of 40 plus square root of 60 all under this big square root symbol. Definitely this is not in the simplified form because we have a radical under another radical. You can pause the video and see if you can solve this Cambridge math problem. Now let's solve this problem together. Let's begin by simplifying this square root of 24. We can write this as square root of 24 equals square root of 4 times square root of 6. But square root of 4 is a perfect square that is equal to 2, then copy square root of 6. That is our simplified form of square root of 24. Let's do the same for square root of 40, that is equal to 2 square root of 10, and square root of 60 is equal to 2 square root of 15. Now let's replace this square root of 24, square root of 40, and square root of 60 by these three results to arrive at this. Then notice that square root of 6 can still be rewritten as square root of 2 times square root of 3. This square root of 10 is equal to square root of 2 times square root of 5. And this square root of 15 is square root of 3 times square root of 5. Next, notice that we have a common factor 2 here. So let's factor out that common factor 2. Now let's recall this identity. The square of the trinomial a plus b plus c is equal to a squared plus b squared plus c squared plus 2 times the quantity ab plus ac plus bc. Now look closely at this part and compare that with this part of this identity. Notice that if a is equal to square root of 2 and b is equal to square root of 3 and c is equal to square root of 5, these two expressions are equivalent in form. So with that as our observation, we now assign these values. Let a be equal to square root of 2, b equals square root of 3, and c equals square root of 5. That way, these two box expressions are equal. Now our next task is to show that this 10 is equal to a squared plus b squared plus c squared. And if we can do that, then this original expression can be written in the form the square of a plus b plus c. And since we know a equals square root of 2, b equals square root of 3, and c equals square root of 5, then we'll be able to find what is the simplified form of the given expression. So how can we prove that a squared plus b squared plus c squared is indeed equal to 10? That's easy. Let's take this a squared plus b squared plus c squared, and substituting these values for a, b, and c, we arrive at this part. And squaring square root of 2, we get 2. The square of square root of 3 is 3, and the square of square root of 5 is 5. And 2 plus 3 plus 5 is equal to 10. Notice now that a squared plus b squared plus c squared is indeed equal to 10. So this box part here equals that box part on top. So we now therefore say that this radical expression at the right is equal in form as the square of the quantity a plus b plus c, where a is equal to square root of 2, b is equal to square root of 3, and c is equal to square root of 5. We now have this result. The simplified form of this original radical expression is now equal to the square root of the square of the quantity square root of 2 plus square root of 3 plus square root of 5. And there is one more step that we need to do in order to come up with our final answer. Notice that we have here a square root and an exponent 2. And so for our final answer, the value of our original nested radical expression is square root of 2 plus square root of 3 plus square root of 5 in simplified form. So thank you very much, and for more videos like this, here is our recommended video. This is Lando Assistant, and we hope to see you again in our next video. Bye for now.